Nous finissons converting logic expression to circuit. Maintenant, je vous get post-exam question. Et l'exemple d'une post-exam question, c'est ça. Maintenant, je ne peux pas trouver aucune expression dans cette question. Je peux trouver une description d'un système. Et vous donne juste une input values. Ça, c'est une valeur qui peut input dans le logic diagram là. Their binary value and what each binary value peut représenter. Par exemple, the output A, si the N will represent a pH of greater than 7. Ensuite, deuxième partie de la question, il donne une description. When an alarm will sound, when telle affaire ou telle chose arrivée, ou soit temperature moins que 35 and pH greater than 7. Maintenant, pour move on to this question, you get one system simple. Dans une description simple, so you have bulb on. This is a description of a system where you have the bulb on and the switch is on. And the bulb line put on when switch goes on. So the relationship between the input and the output is directly related in that when it goes off, the bulb is off. When you switch on, the bulb goes on. In la ligne directe, there is no gate in between. And the expression is output is equal to A. Now if I change this on to off here, nous avons seulement une partie. So how are we going to work this out? So here you have the bulb is on. If A is equal to 0. Maintenant, si nous passons par une truth table, je peux guetter. Alors, quand A is 0, bulb là pour on. Therefore, when A will be switched on, bulb là pour besoin 0. So this is the opposite of the value of the bulb. So bulb is equal to not A. Maintenant, à chaque fois que je gagne 0, je dois convertir 0 là en 1. So 1 is 0 is not 1. So the expression is equal to A is equal to not 1. This is the value of A. So bulb okay, how do we draw it? Bulb là les avez ici. Input A ici. Alors, we should have the value. So if this is not A, bulb is equal to not A, so this line is not A. Bulb and not A are the same thing. Alors, not gate gives a rond ici. So we can have the input of A. Right. Alors, je rappelle ça qu'à chaque fois qu'il peut être à 0, je dois convertir 0 là en not 1. Next, the third one, a bulb is on when either C is on or D is on. C'est analyse simple. Je peux trouver qu'il y a O gate un petit peu flou, mais I'm going to read it out to you. This is O gate. So C is on or D is on to produce a value of on for the bulb. So how is it going to be? Si nous passons par une truth table, je peux trouver logiquement. So this is C, this is D, this is bulb. Qu'est-ce que ça veut dire? Either C is on or D is on veut dire soit C allumé, soit D allumé. Ici, non, il n'est pas allumé, bulb là, putain, il va pas allumer. Ici, D allumé, alors ce bulb là pas allumé. Ici, C allumé, bulb là pas allumé. Ici, tout le D allumé, bulb là pas allumé. But If we analyze the sentence itself, the word O is itself the gate. So B is equal to 1 if C is equal to 1, O D is equal to 1. Okay, so it will be nous enlève ça n là, nous pas besoin ça. So it is going to be C O D, and the circuit will be because it is bulb is equal to COD, it is bulb will be, this is C, this is D. Okay, so you just have to read out what is written as the gate. Next, you have the bulb B is on if switch C is on and D is off cette fois-ci. Auparavant là je tiens on, maintenant je tiens comme off. So what is going to happen here? So let us write this one. B is on if C is on and D is off. Alors, B bulb equal to 1 if C is equal to 1, O D is off. So which D is off? D is equal to 0. Right. So as we have said earlier, quand on a 0, je dois convertir en 1. Alors, ça 0 là, we pouvons not 1. So the answer will be C is equal to 1 or D is equal to not 1. Alors, nous enlève pour tout côté là 1 maintenant, pas besoin de. So it is going to be bulb is equal to C or D not 1. So this is a NOT gate. So I'm going to write NOT D. Okay, now how do I construct it? This is the gate in between the two lines. So I am going to draw my O gate first. So the output is bulb. And here I'm going to have my line C. And here I am going to have my line NOT D. Now this is not an input value, it is an expression. D must have gone through NOT gate to become NOT D. So I am going to draw my NOT gate to get the input of D. So this is the answer. Okay. Alors, reliez la question, essayez de travailler. Ensuite, next video we are going to take a look at post exam question.